All right, in this video, we're going to find the interval of convergence for this power series, this one right here. Okay, so I wrote it down below. Now to do this, whenever you're trying to find the interval of convergence or the radius of convergence, you're going to use the ratio test. So that looks like this here, the n plus first term divided by the nth. Okay, so the n plus first term would look like this. So the only thing at risk in the expression here, right, remember this right here is a sub n. That's the formula for any term that you're adding up. But the only thing at risk of not being positive is the x minus 3. So that needs to be hugged by absolute values. So this is going to be the n plus first term. Wherever there's an n, we put an n plus 1. And then we divide by the nth term. So again, just to color code for those who are, right, what I just wrote down was this, the n plus first term. And I'm about to divide by the nth term. But rather than divide by the fraction that'll emerge, we're just going to multiply by the reciprocal right away, just to save on some writing. Okay, so the reciprocal of the nth term would just be this. Now some canceling can happen here. Let's see what happens. So this 2 can cancel with that 2. I have n copies of that, and I have one more copy of it here. So I'll leave behind one absolute value of x minus 3. So all cleaned up, I have an absolute value of x minus 3 times an n over an n plus 1. And now we take the limit of that as n goes to infinity. So the limit as n goes to infinity. Now, you're welcome to take this x minus 3 outside the limit because it doesn't have any n's in it, so I usually do that. It's kind of a stylistic thing over n plus 1. Okay, so now you focus your attention on what is this limit going to be. Now that, hopefully you see instantly, is just 1. So, by the ratio test, we get absolute value of x minus 3 times 1. Now, to apply the ratio test, remember, what we want to have happen is we need this to be less than 1. It's the same criteria as like a geometric with the common ratio. So we need this to be less than 1. So now what we're going to do is we're going to see what values of x make that true. That becomes our interval of convergence. So based on, what we're going to write this as a double inequality now, right? So now I've got -1 less than x minus 3 less than 1. Add 3 everywhere. So now I have 2 less than x less than 4. Okay. Now we're almost done. This could be our interval of convergence, but the ratio test never gives you information about the endpoints. Okay, and so the endpoints mean 2 and 4. So what you have to do now is plug in 2 and 4 individually and analyze the series that result for each of those endpoints. So I'm going to say check endpoints. This is something, if you're taking the AP exam, probably often forgotten by students. It's worth at least a point, probably a point at least. Okay, so let's just plug in x equals 2. So go back to the original series, and if I put a 2 in the spot of an x, okay, I'll just write it out. I'm going to get 2 minus 3 to the n divided by 2n. Oops. This n goes from 1 to infinity. Okay, so let's clean this up. 2 minus 3 is -1, so I get -1 to the n divided by 2n. All right, now usually at this point I'm going to stop writing because I kind of just want you to do the thinking if you're in my class. We want to know if this converges. It's an alternating series, so the question is, does it converge absolutely or conditionally? Well, it does not converge absolutely because, I'm just going to note this. Does this converge absolutely? No, because the absolute value of the terms would look like this, would be 1 over 2n. And that diverges. It's a p-series where your p is a 1, and the 1/2 is not really a problem. Does it converge conditionally? It does, because basically all you need to check is ignore the -1 to the n part. 1 over 2n, is that always positive and decreasing to 0? I realize I just said I'm not going to write, and here I am writing. But mainly just try to help you think and piece the ideas together. It is. So it converges conditionally. And we're going to go right up here for this 2. We're going to include a little or equal to. Okay, let's check 4. Okay, check x equals 4. When you plug 4 in for x, I get 4 minus 3 to the n over 2n. Which results in 1 to the n, but that's just 1. Now, does that converge? First of all, it's not an alternating series, so you don't have to ask like absolutely or conditionally. It's always positive. It's not oscillating. So, does this converge? Well, no. This is clearly a p-series where p is 1. And what we really wanted, if p is less than or equal to 1, that means it diverges. So, it diverges. Okay, so 4 didn't work. So we don't do anything over here on the other side of the equality for the 4. Okay, so our interval of convergence includes the 2, and we're going to write that. Now the radius of convergence, just if you want to think visually, your radius of convergence, right? Remember this series is centered at x equals 3 clearly, so I'm going to put 3 in the middle. I'm going to put 4 here. I'm going to put 2 here. Your radius of convergence is just this distance here from the center to either endpoint in the interval of convergence. So that's clearly 1. It's also always going to be represented when you see this structure here. Clearly, like when you have, absolute value of x minus whatever your center, less than a number, that number is your radius of convergence, okay? So that's not an accident, but you could always just draw the visual like I did. Okay, so let's go fill in the blanks now above, just to complete the scaffolding here. And this is meant to kind of help you just synthesize the ideas. I applied the ratio test and the interval of convergence. I found before checking endpoints was just 2 to 4. So if we use this notation, this is maybe it can fit in there. When I plugged in the left endpoint, I found that the series converged conditionally. And when I plugged in the left endpoint, I found that the series diverges. Therefore, my final interval of convergence is, so I'm going to include the 2, 4, no, and the radius of convergence is 1. Okay, so let's just kind of zoom out. I'll do the right one in another video. Okay, there we have it. This is the work. Some intense stuff, but ratio test, check endpoints. That's the lesson to hear, the lesson from this video. This is a finite interval of convergence. The other two situations that can happen is only one number works or everything works. The interval of convergence is negative infinity to infinity. So we'll see that in another video.